62 में he gave you the potential of this. Can you find out charge here? He gave you R and potential here. So it will be only because of a charge at the center. Right? So once you know the charge, you can find out the potential anyway. Or vice versa. You know the distance, you know the potential difference divided by distance. Find out the charge at the center. कहीं पर भी potential calculate कर पाओ.
Sir, so in 62, can you do A also?
Done in the class. Done in the class. Class notes.
Oh, okay.
22. Two identical balls, each having a charge of this mass suspended common point between insulating strings. Both are at a separation of 5 centimeters. Electric force on one of the charge component of the resultant force on it along and perpendicular to the string. Tension in the string, acceleration of one of the balls at the instant. 22. You have two bodies this way. Both are identical, Q and Q. This will be P. This will be T cos theta. This will be mg. You are releasing it from the position. Some distance of 5 centimeters is given, if I am right.
Yes, sir.
The balls are held at a separation of 5 centimeters apart and then released. This distance is 5 centimeters. So will I get the electrostatic repulsion? This will be T sin theta. Right. What is the resultant acceleration along the length of the string?
0.
Perpendicular to the length of the string. You're releasing it from here. Right? You're releasing it from here. That means velocity is 0. Velocity is 0, centripetal acceleration will be 0. Or even if not, do calculate P minus here. You're releasing it at theta. So mg cos theta and Fe sin theta. This will be theta. This will be mg cos theta plus Fe sin theta. You will get T. He asked you even tension, if I am right. But bottom line, you released from here. Whatever is the acceleration, it will be only in this direction. Centripetal acceleration will be 0 as because the velocity is 0. So from that, I will get the value of T. T is equal to this. Now, tangential acceleration, you can calculate. You know mg, you know Fe, you know T. T will not contribute to AT, but component of mg and component of Fe will contribute in this direction.
Yes.
22nd, do I do the simplification further or will you be able to solve?
So I will be able to solve. Thank you.
Okay. The next problem I see is 26, if I am right. 26. Particle having a charge, this is placed directly below and at a separation of 10 centimeters from the bob of the simple pendulum. What charge should the bob be given so that the string becomes loose? String will become loose. Some charge is given and what charge is kept? Which question am I discussing? 26. What charge should be given so that the string becomes loose? Where is the charge kept? At a separation of 10 centimeters from the bob. There is some capital Q kept here. So electrostatic repulsion should be equal to mg. That's it. The tension will become 0. K capital Q small q by this distance, if I take as R square is equal to mg. The tension will become 0. Can I rub the bow?
Can you also do 23?
20.
3.
23. Same thing, no, yaar, like 22nd. What is the difference? The only difference is 23 may you have kept the two bobs like this. So they will come like this. This is T. This is T cos theta. This is Fe. This is T sin theta. T cos theta and G. Will this hint be sufficient or do I have to solve this further?
No, sir, it's sufficient.
26. We just now did this. Where do we stand? 32. Not fair. What should be the electric force experienced by it? Show that the force is under what conditions will the particle execute as such a gravitation may exactly the same problem has been done. Capital Q and capital Q is fixed. Small q should be displaced to the right by a distance of x where x is much lesser than d. Electrostatic repulsion between these two is K capital Q small q by d minus x whole square minus K capital Q small q by d plus x whole square should be equal to m into d2x by dt square. Small q I displaced to the right. Repulsive force of this is this value. Repulsive force of this is this value. This will be lesser, this will be greater, so it will push it back to the equilibrium. On the contrary, just for your information, if it were minus q, then displace it in this direction. X and y are on a smooth table. You are having the top view. You are displacing y towards you. It will come back this way. X is this. First example is this. Capital Q fixed. Particle oscillates this way. This particle oscillates this way. Right? This will be attracted towards this and this. Restoring force is 2F cos theta. Restoring force is 2F cos theta. Substitute F and cos theta equated to m d2y by dt square. You get K capital Q small q by this distance whole square. D square plus y square. Cos theta will be y divided by root over of d square plus y square. We have done this in gravitation. In electrostatics, the only difference here is plus q, it will be moved to the right and left. See if you are convinced. 32nd. Do I have to do the simplification further or will you be able to solve?
So I'll solve.
Sir, could you add 48 part B, C, D?
Let me come to there and back. (41) भाई कितने बार की कर चुके हैं यार सेम थिंग यू पीपल मेक अस Take a finite length of the wire. Gravitation may be kiya, same problem. At a distance of 41, 10 centimeters long, magnitude of the electric field at a distance of 10 d. Consider an element dy at a distance of y. This will be d. Agreed? This is theta, this is theta. This is de cos theta, de sin theta. People, when you people are asking doubts, एक बार class notes खोल के तो देख लो. De sin theta will get cancelled out. What are we left with? De cos theta. Small element 2, because of the small element k dq by this distance whole square, y square plus d square. Cos theta will be d upon root over of y square plus d square. Integral of k lambda dy d upon y square plus d square to the power 3 by. First to convert this, bring k and lambda outside. K and lambda. Convert this in terms of theta. Convert this in terms of theta. How do you want me to convert that? Tan theta is y by d. Y is equal to d tan theta. Dy is d secant square theta d theta. Substitute y is d tan theta dy. What will be the least value of theta? It will be minus alpha. Maximum value of theta is plus alpha. Least value of theta is minus alpha. Maximum value of theta is plus alpha. You know the value of alpha because length of the rod is given and d is given. Will you be able to calculate alpha?
Yes.
Haven't we done this in gravitation?
Yes, sir.
Gravitation
Sir, I was just confused about the d equals to 10 centimeter part. I didn't understand what they meant by 0.10 centimeter from
Actually,
10.
same language was used even in gravitation. The assignment sheet given to you, may you have this problem as kindly look into your notes before
So,
you are
but the
completing
diagram
all
was
the-
given with that problem, so it was easier, I remember. So, anyway.
Are you listening what I'm saying?
Yes, sir. You said to look at the notes.
I said same problem. Values change हुआ तो नहीं होगा हमसे.
No, sir, I just didn't understand the language. Values and all is fine.
अंग्रेजी में दिया हुआ है गलती हो क्या बोलूंगी आपको 45. Positive charge Q is placed in front of a conducting solid cube at a distance of d. Electric field at the center of the cube due to the charges appearing on the surface. Temporarily remember this till I complete Gauss law. Q. There will be induced charges in such a way such that these both together will give me zero field everywhere inside. This I will cover in detail in shielding. Till then, remember one thing, field inside a metal is zero. He gave you charge here. This charge will produce some field here. Q induced will produce an equal and opposite field here. This charge will produce some field here. Q induced will produce an equal and opposite field here.
Okay, sir.
Well, in detail shielding, this concept I'll be covering in shielding probably in one lecture from now. So till then, remember only one thing, so-called Faraday's state, field inside a metal will be zero.
Yes.
Okay, sir.
So Q induced will produce an equal and opposite field due to this.
So can you explain the direction? I was getting the direction wrong when I was solving.
Opposite directions. This plus this should be zero. If Q will give me a field to the left, Q induced will give me field to the right.
Yes, sir. Okay. Got it, sir. And same magnet.
Same magnitude. Because net field should be zero.
Yes, conducting.
Somebody in between said 48 or something.
48.
Particle of mass m and charge, this is released from dust in an electric field. The electric force and force of gravity acting on this particle. Can one of these forces be neglected in comparison with other for approximate analysis? How long will it take for the particle to travel a distance of 40 centimeters? What will be the speed of the particle after traveling this distance? How much is the work done by the electric force on the particle during this period? 48, may kindly tell me your doubt.
Sir, part B, C, D.
How long will it take for the particle to travel a distance of c? Did you calculate mg and dq?
Yes, sir.
How much did you get?
Sir, I don't remember. I'll have to check.
M is 1 gram, 0.001 kg into 10. Field is 1.2 into 10 raised to 4 into Q, 2.5 into 10 raised to minus 4. Am I right? Hope I have taken the values correct. This is 0.01. This is 1.2 into 2.5. Pardon?
3. 1.2 into 2.53
2.5 into 1.2.
is 3.
Yeah. This is much greater than 0.01.
Yes.
So
Yes,
this
sir.
will be negligibly small.
Yes, sir.
So when I am calculating the acceleration, it will be 3 divided by the mass. 3 divided by 0.001. This will become 3000 meters per second square. If I have taken the units correct, I didn't observe the units here. M, force divided by mass. Mass is 1 gram. 1 gram is 0.001 kg, right? 1000 grams is 1 kg. Yes or no?
Yes, sir.
Now, once you know the acceleration, s is equal to half at square. वो time पूछ रहा है, distance दिया हुआ है. How long will it take? What will be the speed of the particle after traveling?
सर
this
हो
distance?
जाएगा बाकी का.
क्या क्या डाउट्स पूछते हो यार, दिल बैठ जाता है यार जब आप लोग डाउट्स पूछते हो. ऑनलाइन जब लेता हूँ और मजा लेती हूँ. ये तो 9th 10th स्टैंडर्ड में क्लियर किया हुआ है, कॉन्सेप्ट्स है.
Sir, I took both the forces, which is why I was getting a different acceleration.
है कैसा ले
फिर भी
लोगे?
सेम ही आएगा।
ले भी लिया आपने तो भी आंसर सेम आएगा. पता है क्यों?
3000 के सामने 0.2
3.0. Then what will your answer come? 3 plus 0.001 or 3 minus plus or minus 0.001. क्या फर्क पड़ेगा? आंसर तो सेम आएगा. थर्ड डेसिमल प्लेस में डिफरेंस है. $50 50 Simple pendulum, bob, 20 oscillations, put the electric field upwards, magnitude T is 2 pi under root L by G effective. How much is G effective? G minus EQ by M. Once I know the time period, 20 oscillations, 30 oscillations, 40 oscillations, जो मन में आए solve. How much time does it now take to complete 20 oscillations? Find the new time period, बाकी सब आ जाएगा. Here, why are you taking G minus? EQ is in the upward direction. Okay. Say something. Find the
60th B part only.
50th.
60th, sir. 60th question B part only.
Find the expression for the electric field. Potential कितना दिया हुआ है? A into
A into
XY
plus
plus
YZ plus XZ.
YZ plus XZ. Field is minus dV by dr minus of I cap del V by del X plus J cap del V by del Y plus K cap del V by del J minus of I cap. Differentiate this with respect to X.
Yes, sir. Y.
I get Y plus Z, right?
Yes.
J cap, differentiate this with respect to Y, X plus Z. K cap, differentiate this with respect to Z,
X plus
Y
Y.
plus X.
Yes, sir.
If I recognize the voice, well, is this closest voice?
Yes, sir. Yes.
This is a very easy problem. You are not supposed to get this as a doubt.
Sorry.
71. Two particles placed at a separation of 1 centimeter. Write down the electric dipole moment. Electric field at a point on the axis of the dipole 1 meter away from the center. Electric field at a point on the perpendicular bisector. See, 71 may I believe in the current editions of HCV, he has made a correction. Kindly tell me the values. I have the old version of HCV, but last year I remember when I was taking doubts, your senior batch told me in the online lecture that the values have changed. This is 2 into 10 raised to how much?
Minus 6.
Minus X.
Minus 6.
Negative 1 is 2 into 10 raised to minus 6 positive. Length is 1 centimeter. Am I right?
Yes, sir.
Yes.
Now, dipole moment, how everyone will calculate. P into L, please take same units. At this stage, I will not be telling you people to convert CGS into SI units and all that. You people are well versed with that, right? Now, this R, if it is 1 centimeter, then the formula for potential that we derived will not be applicable. Why?
R is not much lesser than.
Right, R should be much greater than N, much lesser than N. R should be much greater. 1 meter jab denge, so I will be able to use the formula of P cos theta by 4 pi epsilon naught R cube. 1 meter ke liye, the formula is applicable. You give me 1 centimeter. In the old edition of HCV, I have been given 1 centimeter. To my knowledge, that is 1 meter. Correction was done in the new editions, is what students, I vaguely
Yes, sir,
remember
1
students. So then you can apply P cos theta by 4 pi epsilon naught R. P value is this into length. This is in coulomb, this is in centimeters. Please convert centimeters to meters. Abhi kar paoge? Say something.
So, but the angle is not given right. So,
Calculate the electric field at a point on the axis of the dipole. Axis of the dipole, no, yaar.
acha, yeah,
Away
right.
from
Sorry.
the point. Axis of the dipole means it will come along this direction.
Yes.
Perpendicular bisector comes this way. Axis means this one. I hope you are clear about it.
Yes, sir.
So theta will be how much in when if I am asking along the axis?
0 degree.
Can I rub the board?
So can you look at 60-second problem for a minute? So you said you had done it in class, but so have you done it in flagship data? 60-second problem.
Generally, I deal with that. I don't miss that. In equipotential surfaces, this is 0, this is 1 centimeter, 2 centimeters. 10, 20, 30, 10, 20, 30, 40 volts. This angle is 30 degrees.
Yes.
Divided by 1 tan 30. Resultant of this is my answer, but I will not do whole of this. I know the resultant direction. How do you know the resultant direction? Field lines will be, the field will be perpendicular to the equipotential surface.
You're lagging.
So you had lagged for a minute, so we could not hear anything.
Yes.
So you're lagging again. So you're now back.
Am I back?
Yes, sir.
Yes, sir. Yes, sir. You're back.
This is happening only with flagship batch. Why I don't know. Yesterday I have taken a doubt lecture for another batch. It went smoothly. Only with flagship batch. Now, listen. Ex and dy.
It's frozen again.
So you have frozen again.
I think now you're back. But the screen is small right now.
So the video quality is not very good.
Yes, sir.
Okay, let's at least complete this question. The resultant field will be in this direction, right? Resultant field will be perpendicular to the
Yes, sir.
equipotential surface.
Yes.
So you don't need to calculate Ex and Dy. You know the direction. So once you know the direction, the resultant field will be 20 minus 10 divided by this distance. 20 minus 10 divided by 1 sine 30. So many volts per centimeter is my field. Is the logic clear?
Yes, sir.
If not, calculate Ex and Dy separately and take the resultant, you will get the same answer. By the way, how do you know that the resultant is in this direction? It will be perpendicular to equipotential surface.
Yes, sir. Field lines are perpendicular.
Yes, sir.
Above all, okay. Even if they are perpendicular, they will be in this direction or this direction. How do you decide that? They will be in this direction from higher potential to
Lower potential.
Sir, what if it was 40 instead of 30?
the field is non-uniform. Then he will have to tell you which area he wants the field. Now field here, field here, field here, if it is the same, he'll ask you for the field. If field is changing, he'll ask you field in this region, field in that region, so on and so forth.
Okay, sir.
So can you take objective doubts also?
Yes. I wish network doesn't disturb us.
So now it's good, guys.
It seems fine, yes.
Thank God. Now 72. Hey, 72. This is Q, this is Q, this is minus Q minus. Negative, positive dipole, there is one dipole, negative, positive, there is one dipole. Find the resultant of these two. Find the resultant of these two. 72 जिसका भी doubt है, will you be able to solve? (73) Seabed. Find out the potential due to the dipole of minus Q and plus Q, and then Q separate. See, I have minus Q here, Q here. Will I be able to calculate the potential here due to these both?
Yes, sir.
How much is that? How much is that?
So P upon 4 pi epsilon naught dq.
Formula for potential below.
So one second, I'll have to open my notes. I've forgotten it.
For exam में क्या करोगे?
So I'll revise all the chapters before doing it.
P cos theta by 4.
Cos थीटा कैसा भूल सकते हो यार? बाकी बोल के cos थीटा आपने छोड़ दिया यार. Theta is how much?
Sir, R square.
Theta is how much? Cos 90 is how much?
0.
If that is 0, the only leftover charge plus Q will give you how much potential? Sorry, he asked for field. I calculated potential. Make the correction, but the procedure is the same. Field यहाँ calculate करना है तो
लैग हो रहा है दोबारा.
R and D theta.
नहीं हो रहा है सर.
Oh, sir, it's not lagging.
Pardon?
किसी ने लैग हो रहा है बोला तो हमने बोला कि
Sir, नहीं हो रहा,
It's
नहीं
not
हो रहा,
lagging,
कुछ
sir.
lag.
Pause.
Okay, listen. Because of minus Q and Q, you have got ER and E theta. ER E theta formula अगर याद है तो अप्लाई करो, वरना नोट्स से देकर कॉपी करो, 10 बार कॉपी करो ताकि याद रहे. Is it clear? Now, one of the expression will become 0. Why? Because one of the expression is cos theta. Theta is 90 degree here. Cos 90 is 0. Take the other charge. Because of the other charge, find out the field. It will be along this direction. Can you get the resultant? Say something. Yes or no?
Yes, sir.
Yes, sir.
Firstly, shall I complete short answer question 1 to 7?
Yes, sir.
Short answer question 1. The charge on a proton is this and of an electron is this. Does that mean that the electron has a charge of
No.
3.2 into 10 raised to minus 6 coulomb, minus 19 coulomb, less than the charge of a proton? Yes.
तो वो
Result-
सब नेचर है ना, तो नो होना चाहिए ना.
Pardon?
तो प्लस माइनस इज जस्ट नेचर है ना, तो आइडियली नो होना चाहिए ना.
I have no problem. See, potential define करते वक्त, you have a battery, plus and minus लोगे. You will tell me this is minus 6, this is 0, we are okay with. 0 and 6 we are okay with. Right? 6 and 12 we are okay with. Difference should be 6. Same applies to this. I have 1 plus 2, the other man. Oh no. 1 second. He must have meant in that case, if I take 0, no, listen. This is not potential, this is charge. This is not potential, this is charge.
Does it
My
mean excess of
mistake.
electrons and
As far as the charge is concerned, one is positive, one is negative. I cannot make one 0 and the other 3.2 because if one is 0 and the other is 3.2, or I make both of them positive the way I have done it here, 6 and 12. Now the two charges will repel if I make both positive. They don't repel, they will attract. Magnitude difference may be the same, but like charges repel and unlike charges attract. So I cannot make the negative charge positive. That applies to potential, not for charge. Make the correction. Is this clear?
So we say no, na?
Pardon?
To the question we say no, na?
For the question, the answer is no. Second question, is there any lower limit to electric force between two particles? Yes.
Least charge.
Minimum charge I can have is 1.6 into 10 raised to minus 19.
Yes.
I cannot have a charge lesser than that, so that will be the lower limit. Seven. 4 pi lines. Did I introduce Gauss law?
Yes.
Yes,
Yes,
sir.
4 pi, recollect closed integral E dot ds. I am getting q by epsilon naught.
Yes, sir.
Right. If 4 pi cancel, tabhi hoga if I had a 4 pi here. Yes or no?
Yes, sir.
Now the second part of the question is, he's asking, how can you have so many lines of force?
Imaginary.
Lines of force are imaginary. I can have any number. I can have even half a number. Lines of force are imaginary. Hence, 4 pi doesn't interfere. Lines of force don't exist at the first place. We are making you visualize flux using number of lines intercepting a surface perpendicular. 14. When a charged comb is brought near a small piece of paper, it attracts the pieces. Does the paper become charged when the comb is brought near it? No. When a charged comb is brought near bits of paper, right, the paper is insulated. There will be induced, if I have positive charge on the comb, there will be induced negative and positive. Dielectric, paper is a dielectric, so it should form a dipole. When it forms a dipole, the negative charge is closer to the positive charge, hence it will attract. But for that, neutrality of the paper is maintained. Paper doesn't acquire charge. Reason being, comb will produce a field which will not be equal to the dielectric breakdown of paper. For an insulator to be converted into a conductor, the dielectric breakdown is quite high. I should produce a very large field. Only then the paper can be converted into a conductor. So paper only works as an insulator. Charge is not relieved of it. So paper doesn't get charged.
Sir, I wanted to confirm the reasonings of a couple of questions in objective 2.
Bolo.
So question number 6 में the electric force on dipole cannot be 0 because the field is non-uniform, right?
एक सेकंड रुको, क्वेश्चन देखो, 6
Yes.
बोल रही है ना,
Yes, sir.
एक सेकंड. Question number 6. Objective 1 or 2.
2, sir.
An electric dipole is placed in an electric field generated by a point charge. Point charge will obviously give me
Non-uniform field.
non-uniform field.
Yes,
So
sir.
it is minus Q and Q. Force is not equal to 0.
Yes, sir. And sir, in the fourth one, in the case where the electric field can be greater than 0, is it because of other components acting like there is an angle between field and
Right. Fourth question में he is telling you at x equal to -1. -1. You are telling me this is 120 volts and this is 80 volts. Am I right?
yes, sir.
Now this equipotential surface can be this way. Now distance between them need not be 2 centimeters. It can be less than 2 centimeters.
Yes, sir.
So
Got
field can be greater than. It's a very beautiful question. The fourth question.
Yes.
You take 120, you take 80, you will take 120 minus 80 divided by this. That you will get only x component. That can even be a y component. So resultant will be root over of ex square plus ey square. Lesser than that.
So can you also take short answer ka 12?
So can you do third of objective?
Objective 1 or objective 2 ka third? 2 ka third. None of the options are correct. Have a look at the first bit. He says field is 0, potential must be 0. Field is 0, potential must be 0. This is wrong. Hollow sphere. Take a hollow
Yes, sir.
sphere. Field inside is 0. Potential is not 0. Second option. Potential is 0. Field must be 0. ये भी गलत है. Why? Potential take minus Q and Q. At the center, field is not 0, but potential is 0.
Yes.
Third, if field is not equal to 0, field is not equal to 0, right? We cannot be 0. We cannot be 0. Cannot be 0. This is also wrong. Here field is not 0. Potential is 0. Same example. He's playing with words. If potential is not 0, field cannot be 0. Field cannot be 0. Wrong. Potential is not 0. Field can be 0 inside a hollow spherical shell.
Oh, yes.
Very well played question by HCV. Short answer में कोई कुछ बीच में बोल
No,
रहे थे.
12.
It is said that the separation between the two charges forming a dipole should be small. A million times we have answered this question. What is the approximation done in dipole?
तो अंदर का डिस्टेंस है वो जिसके रिस्पेक्ट में सॉल्व कर रहे हो उससे कम है. मतलब जो दो चार्ज पड़ा है.
Are much greater than n.
Right.
Dipole theory में what was the approximation that we emphasized a lot? R is much greater than what?
Distance between the charges.
R is much greater than what? Can you give a simple answer?
2L.
Length of the dipole. Am I right? With
Yes, sir.
respect to Earth, with respect to an accelerated frame, with respect to relativity, with respect to Einstein. क्या बोलते हो आप? R is much greater than the length of the dipole. Haven't we repeated this a million times?
Yes, sir.
That is what he asked. Don't make things complicated for yourself. Relativity तक पहुंच जाते हो, एक short answer question answer करने. Is this done? HCV field and potential completed.
Yes.
Can we take the assignment sheet?
Yes.
Is the network clear?
Yes.
Yes. So question 11.
In the first 25 problems, first of all.
So 11.
So 5 and 7 also.
11.
11 लिखा हुआ है.
So 9.
7.
So 24.
Assignment 1, right?
हाँ, assignment 1. First 25 problems.
16.
25.
So 48.
First 25 में 48
25.
आता है.
अच्छा सर मैं नहीं था.
Question number 5. Electric charge Q exerts a force of S on a similar charge Q separated by third charge. He is playing with words here. This Q and Q, force exerted on this by this is not dependent on any other charge. Now I will bring center chodo. I will bring some charge here as Q by 4. Force on it due to this will remain the same. This will not change. Because of this, there may be an additional force and the net force on it may change. But force on Q due to Q will remain the same. It is not affected by the presence of a third charge. This force will be K, Q, Q by this distance R square. This will be independent of the presence of the third charge. Only thing, net force on this may change. Is the fifth question clear?
Yes, sir.
It's important. That is called principle of superposition. Superposing n number of forces on this, all will be independent of each other. 7th is an easy question, but for reasons not understood, every batch is asking that is a doubt. This is R. Can I calculate the value of R? You gave me X as 1.2, Y as 1.6. R is root over of 1.2 whole square plus 1.6 whole square, right? So here field will be in this direction, KQ by R square. Iska horizontal and vertical component. This will be E cos theta, this will be E sin theta. Can I report the answer? Hey, R also I don't have to calculate. Foolishness, that is already given as 2. R is 2. So if R is 2, you know this theta. E cos theta, E sin theta, I cap, J cap.
So R को unit vector में लेकर भी कर सकते हैं.
There is a small change. If Q is
Yes.
negative, field will not be this way. Field will be this way. This will have horizontal and vertical component this way. This will be horizontal, this will be vertical. If it is minus. कोई कुछ बोल रहा है, मुझे सुनाई नहीं दे रहा. Seventh question, is it clear to all?
Yes.
Question number 9. Four identical charges fixed at the four corners of a square. Electric field at a point P located symmetrically at a distance of a by root 2 from the center of the square. I thought I dealt with this in the class. Didn't I deal with this in detail? I even told you people that if I keep it in the horizontal plane,
Yes,
it
the
becomes
students can
easy for you to
visualize it
calculate.
better.
In detail बोला हुआ है a by root 2. Because of 1 I will calculate the force. Iska vertical will get added up, horizontal will get cancelled. This field ka, if it is theta e cos theta into 4 is my answer. You know this distance a by root 2, that is a by root 2. Using Pythagoras theorem, you should be able to calculate this hypotenuse. कर पाओगे अभी? याद आया? Ninth problem जिसने भी पूछा, now are you able to recollect?
Sir, I thought it was actually inside the plane of this thing. That's why the simplification was going horribly bad.
Now you understood what it is?
Yes, sir, we did this in class.
No. 11th one, it seems the answer given is not matching. This is in equilibrium, this angle is 15 degree. This will be T cos 15 and this will be mg. This will be T sin 15 and this will be electrostatic repulsion. Right? Suppose I dip this in a liquid of density something, the angle remains the same as the question given. T cos 15 plus buoyancy, don't forget that, is mg. This will be T sin 15. This will be Fe by epsilon r. Fe will be how much? K Q by, this distance is 12 sin 15 whole square. This divided by epsilon r I will get here. T cos 15 plus buoyancy is equal to mg. You know how to calculate the buoyant force?
So won't the tension change?
Makes no difference because I have not solved this with this. Right? Take it as T dash because here T I will eliminate, here T I will eliminate. Take T dash. T dash, T dash. Sin 15 is equal to Fe by epsilon. Eliminate T dash here, eliminate T here. T cos 15 is mg, T sin 15 is F.
Sir, just a small doubt. Sir, we can take components of tension only when it is in equilibrium, right? Not when it's moving.
It is moving. जिस direction में accelerate कर रहा है, if you take components in that direction, equate it to mass into acceleration.
हाँ तो जब वो tangential acceleration होगी तब हम नहीं ले पाएंगे ना T के components.
Naturally.
Okay.
If you have a tangential component in this direction, you released it from here and it's not in equilibrium. Velocity is 0. So it has tangential acceleration. So there I cannot equate T cos theta equal to mg because their components in this direction are unbalanced.
Yes. Okay. Thank you.
Can I rub the board?
So this question on simplifying, I got 1.05.
It seems the answer is not matching. Your students told me that I'll make the change in that key. 11th question.
Okay, thank you.
Question number 16. Three charges placed on the three corners of an equilateral triangle. System is in equilibrium. 16. This is capital Q. This is capital Q and capital Q. This will have electrostatic repulsion. This will have electrostatic repulsion. Because of these both, can you calculate the repulsion on this?
Yes, sir.
Now, iska vertical component will be this. This is theta and theta, right? This will be 2Fe cos theta. I should have a charge Q which gives me an equal force in the opposite direction. For this to be in equilibrium, charge Q should be negative, but it should give me an equal force. If I can find out this distance, which will not be difficult for you because that is the centroid of the triangle. Centroid of the triangle divides the median in the ratio 2:1. So will I be able to calculate this line?
Yes, sir.
So force on capital Q due to small q should be in the downward direction. Magnitude should be 2Fe cos theta. Will you be able to solve now?
Yes.
Say something.
Yes, sir.
Twenty-four. Proton, deuteron and alpha particle are accelerated through a potential difference of proton का charge कितना है? Q.
1.6.
Q plus Q or plus E. Proton का charge is plus E. Agree? Say something. Right? Accelerated through a potential difference of V. Half mass of the proton into V square. Their velocity will be velocity of the proton. Right? What is the charge of a deuteron?
E plus.
E. It is work done. E into V is how much? Charge into V is work done. That's why I'm equating into kinetic energy. E into what is the potential? 2V. Mass of a deuteron into velocity of a deuteron whole square. What is the charge of an alpha particle?
2E.
Charge of an alpha particle?
2E.
So plus Q. I mean plus 2Q.
2E
Yeah.
into 4 volts. Half mass of an alpha particle into velocity of the alpha particle whole square. मास ऑफ ए प्रोटॉन, मास ऑफ ए न्यूट्रॉन, मास ऑफ ए अल्फा पार्टिकल के बीच में रिलेशन अगर आपको पता है तो डिवाइड यू गेट डन. People who do not know the mass of a proton and neutron ratio, I don't want the exact masses. Neutron is how many times the mass of a proton, you should know. Alpha particle's mass is how many times the mass of a proton, you should know, so that you can divide. Twenty-fifth is a very cheap trick played. There is no concept verified in that question. Just confusing the student. Plus Q, minus Q, plus Q, minus Q. They are separated by a distance of A. Find out the initial potential energy. कर पाओगे? Initial potential energy between these two, between these two, between these two, between these two, 4 expressions. Then potential energy between these two and potential energy between these two. 6 expressions you have to add. Will you be able to calculate?
Yes, sir.
Then he is asking, what if you interchange this minus Q and plus Q? Any one. Keep this as minus Q and Q. Now find U final. Initial potential energy between these two, between these two, between these two, between these two. Then the potential energy between these two and these two. 6 expressions. Will you be able to add?
Yes, sir.
Difference is the work done.
Yes, sir. Got it.
Balanced doubts, I'll take it up in the last half an hour of the respective classes. Assignment 1 will be done. To which all batches did I send assignment 2? Flagship 1 and 2, did I send you assignment 2?
So
Not
you
for
send
two.
it to
No,
flagship
sir.
data.
Okay, I've given in flagship 1.
No sir.
So
No.
flagship दादर.
अंधेरी में नहीं दिया है.
सर अंधेरी फ्लैगशिप में नहीं दिया.
Okay. Assignment 2. I'm not speaking about that flux ka 7 problems. No. I'm not speaking about that.
हाँ ऐसा कुछ नहीं है. एक दो ही आया बस. वो
No,
flux
sir,
वाला
अंधेरी में
है.
नहीं आया फिर.
So you haven't sent it to Dadar also then?
Okay. I'll send it right now in 5 minutes. The last 25 problems of this assignment, will take it up in the class in the last half an hour.
So there's a question with coefficient of viscosity. Should I retry that or leave that?
You can try that. Nothing wrong. 6 pi
6 pi
eta
eta
RV. 6 pi eta. वो 9th 10th में schools में पढ़ा हुआ है आप लोगों ने. 6 pi
सर
eta
फ्लूइड में भी
RV.
कर लिया.
फ्लूइड में कर लो.
Fluids में अभी हुआ है कि नहीं?
हो गया.
You can.
Excuse me, sir.
बोलो.
Sir, I have a very small doubt in the question 48 of the assignment. Sir, I just didn't understand why did the charges exactly get half distributed?
Now listen. 48th question में what's happening is one of the sphere is grounded. So you remove the charge on it. Both the spheres are identical.
Yes, sir.
Now what happens is when this sphere comes in contact, you actually kept them suspended from here. If I remember the 48th correct.
Yes.
Yes sir.
One of the ball is discharged. Right? Now what will happen if there is discharge, there is no repulsion between them? So
Yes,
they
sir. So
will
they
come
come
and
closer.
touch each other. They'll come and touch each other this way. You have charge Q on it, capital Q or Q, I take anything, doesn't matter. Now what will happen, because both are identical, charge will flow from here till here in such a way, such that both will come down to the same potential. When will charge flow? From higher potential to
Lower potential.
lower potential. When will flow of charge stop? When both of them are at the same?
Like they are equipotential.
अगर आइडेंटिकल नहीं होते तो भी हाफ हाफ ही हो जाता ना.
नहीं नहीं, ये बंदा फ्लैगशिप 2 से है, इसका आवाज पहचानता हूँ.
हाँ सर.
हाँ, आइडेंटिकल अगर नहीं है तो they will not share the same charge, which will be in detail explained to you in capacitance, first lecture of capacitance.
Okay.
Right now, I am taking the help of symmetry to tell you that both will acquire the same charge, because only when they acquire same charge, both will have the same potential.
Okay.
Right? If they are not of the same size or identical, they will not acquire the same charge.
So is this related to induction or something?
Nothing. It's just related to touching of the two spheres.
ठीक है. So Q by 2 हो जाएगा ना?
Because both the bodies are identical. What if they were not identical? First lecture of capacitance, you will know.
Sir, but even when it transfers a small amount of charge, it will face some repulsion at that instant only, na? So धीरे धीरे.
The transfer of charge is considered to be done quickly here. You are not giving surplus time. The thoda charge जाएगा, repel हो जाएगा. No, transfer of charge is done. If not, they will give you the time lag, which will become very complicated to calculate.
So just we have to change it to from Q by 2 करके वापस वो equation लगा के कर दें.
Perfect.
Okay. So बाकी का you will take in tomorrow's like next lecture.
Tomorrow's class with flagships, last half an hour, I'll finish off.
Sir, the 43rd question answer is correct.
42 का wrong है. 42.
42 का wrong है 2 आ.
हाँ 2 आ रहा है.
42 का
Yes,
answer
that's
is
two.
2. 42 का answer is 2.
Sir, 43.
43 is correct here.
Okay.
43 answer is correct. 43 You know how to solve the problem?
So doubt है.
सर मुझे पाया आ रहा था.
अब 43 का सुन लो, आधे बच्चे चले गए. So listen, 43 का, this is the ring. You have positive charge here and you have negative charge here. Consider a small element like this. If there is an electric field established, this will have E dq in this direction, this will have E dq in this direction. Friction is in the forward direction. Is there any other horizontal force according to you?
No, sir.
So E dq will cancel. F equal to ma is my first equation. अच्छा लग रहा है?
हाँ
बहुत.
Feel good factor, right?
yes.
Second equation अच्छा नहीं लेना. Torque लेना है इसके ऊपर. E dq how do you calculate? Lambda into r d theta. Theta d theta.
Yes.
Right? dq is lambda into r d theta. This is the force into the perpendicular distance. Perpendicular distance, if I have taken this as theta, this will be theta. The perpendicular distance will be r cos theta into 2 integral 0 to pi by 2. एक ही स्टेप में कर दिया मैंने. E into dq is the force. Force into r perpendicular this distance, r cos theta. 2 times क्यों लिया भाई साहब आपने? नीचे भी एक फोर्स है. This is torque due to a couple. कहानी अभी बाकी है. Minus f into r is I into alpha. This is the torque due to electrostatic force. This is the torque due to friction.
Yes.
Don't take friction inside the integral. The integral is meant for this only. Net total torque is I into alpha. Moment of inertia of a ring याद है?
Sir,
A equal to R alpha is my third equation. 3 equations and 3 variables. Your job is done.
yes, sir. Thank you.
सर कल आप फ्लक्स वाले असाइनमेंट का भी डाउट लोगे?
No, tomorrow, last half an hour. Tomorrow has something very important need to be taught to you people. So last half an hour, maybe 20 minutes only, I'll be able to take the doubts. पहले ये खत्म कर.
ओके सर.
Thank you.
Thank you.
Bye, sir. Thank you.
Good night.
Bye.